Okay, so check this out. Yesterday, a story came out in The Telegraph titled Cosmic Dust Left Over from the Dawn of the Solar System Found on Rooftops in Paris. And it's a short article, so if for no other reason than the pure comic relief of it, then just take a listen to this. Tiny specks of cosmic dust, which are left over from the formation of our solar system, have been discovered on the rooftops of 3 European cities. The space debris, which is falling constantly through the atmosphere, has previously only been found in Antarctica and the deep ocean. How do they? Anyways, I'm gonna try not to laugh and comment till the end. It was thought that it would never be found in cities because it would be so difficult to detect amid the pollution, dust, and grime in urban areas. But scientists at Imperial College have confirmed that particles have been found on the rooftops of Paris, Oslo, and Berlin. Dr. Matthew Genge from the Department of Earth Science and Engineering at Imperial College London teamed up with John Larson, an amateur scientist from Norway, to sift through 300 kilograms of sediment that was trapped in the gutters in the capital cities. When John first came to me, I was dubious. Many people had reported finding cosmic dust in urban areas before, but when they were analyzed, scientists found that these particles were all industrial in origin, said Dr. Genge. We've known since the 1940s that cosmic dust falls continuously through our atmosphere, but until now, we've thought that it could not be detected among the millions of terrestrial dust particles, except in the most dust-free environments such as Antarctic or deep oceans. The obvious advantage to this new approach is that it is much easier to source cosmic dust particles if they are in our backyards. Cosmic dust is made up of leftover particles that have been around since the formation of our solar system. These particles are tiny, roughly around 0.01 millimeters in size, and have been falling to Earth since it was formed billions of years ago. Analyzing their chemical and mineral content can tell scientists about how the early solar system has evolved. Most dust is collected by scientists from the frozen wastes of places like Antarctica, as it was thought too difficult to unearth these little time capsules in urban debris. In the study, which is published in the journal Geology, the team reports that the cosmic dust particles that they recovered from rooftops are larger than other particles previously recovered, at around 0.3 millimeters. Based on the particles' size, the researchers' analysis suggests that they were formed by melting during atmospheric entry at speeds of about 12 kilometers per second. Dr. Genge says this would make them the fastest moving dust particles on Earth. Cosmic dust particles contain minerals that make them magnetic, so they use magnetism to separate them under the microscope, finding 500 of them in the debris. The new study also suggests that the dust arriving on Earth has changed over the last million years. The cosmic dust found in cities contains fewer feather-like crystals than old cosmic dust from Antarctica, which has accumulated in ice over the last million years. However, it is similar to cosmic dust that fell on Earth during medieval times, which apparently they date by using the layers of ice in Antarctica. Dr. Genge believes that the difference in these dust particles results from changes in the orbits of planets in the solar system. Over millions of years, the orbits of the planets like Mars and the Earth vary slightly. This causes a disturbance in the gravity they exert and thus influences the trajectory of the microscopic particles as they hurtle through space. In turn, it affects how fast the cosmic dust plummets through the atmosphere and how much it is heated, which causes crystals that grew in cosmic dust to adopt different shapes, revealing the amount of heating. Dr. Genge added, "This find is important because if we are to look at fossil cosmic dust recorded from ancient rocks to reconstruct a geological history of our solar system, then we need to understand how this dust is changed by the continuous pull of the planets." This study was done in collaboration with researchers from the Natural History Museum, London, UK, and Project Stardust, Oslo, Norway. The really interesting thing about an article like this is that if presented to anyone who already sees how ridiculous evolutionary theory is, they're going to instinctively key in on all the references to evolution in the millions of years and all these things, and just the pseudoscience that's clearly being applied here, the pseudoscience and the circular reasoning. And yet, it really is amazing how just a simple little topic like space dust, if you just take the time to look into it for even 5 minutes, I mean, immediately you see how it once again just reveals how Copernican cosmology, in other words, everything we supposedly know about space via science, is absolutely inseparable from evolutionary theory. You can't just pick and choose and extract the things that the secular science say about space and nebulas and the Milky Way and galaxies and gravity and everything, and just ignore everything they say about evolution and accept everything they say about everything else, because they're absolutely intertwined. They're completely inseparable. Everything that they conclude about what they're seeing, what they're measuring, how it all works is all predicated upon the assumption of evolution. And it is no less ridiculous than claiming to scoop a piece of gunk out of a gutter in Paris and put it under a microscope and claim to be separating out the dust particles that came from outer space at 24 kilometers an hour through the atmosphere and melted, and because they have magnetic properties. Because the funny thing is, because it's the same ridiculous circular reasoning that they use in so many other evolutionary geological instances, where they date the fossil by the layer of dirt, and they date the layer of dirt by the fossil, and it's circular reasoning, and it's all based on assumptions. It's the same thing here, because, well, they're claiming that to be able to determine the difference between space dust and Earth dust. Then they'll turn around and tell you that Earth is made from all the same stuff that you found in space. So it's all based on assumption. It's all pseudoscience. It's all evolutionary. It's all just evolutionary propaganda.
I'm an astrophysicist, and I study the interstellar medium in galaxies. That is the gas and dust that exist between the stars. I think dust is one of the most fascinating things in astronomy. We think that there are two different types of dust that exist in space: carbon-rich dust, that's more like soot, and then silicate-rich dust, which is more like sand. But the dust particles in space are actually much smaller than dust that we would encounter on Earth. The grains are tiny. My favorite kind of dust is actually a type of dust called polycyclic aromatic hydrocarbons. Polycyclic aromatic hydrocarbons are rings of carbon with hydrogens attached on the outside, and you can build up multiple rings attached together into different structures. When they absorb a photon, their little carbon skeleton vibrates in specific ways, and that vibration can then emit a photon. When they emit, it tends to be in the infrared, so it converts this energy into infrared photons. Sometimes when a polycyclic aromatic hydrocarbon absorbs an ultraviolet photon, there's enough energy in that photon that kicks out an electron. And this is just a matter of probability. If it kicks out this electron heats the gas in the interstellar medium, and that process is called the photoelectric effect. A lot of my work has been observing those features in the infrared part of the spectrum that come from these vibrations of polycyclic aromatic hydrocarbons. These microphysics are very important because they set the temperature of interstellar gas. Interstellar gas exists in this turbulent state. There's all kinds of variations in density and temperature. There's all of these factors that influence how interstellar gas is organized, but these microphysics of dust are what set the temperature. Dust shields the cold, dense regions where new stars are forming. If dust wasn't there, the UV photons from other stars would be able to go into these regions and break up the molecules that are necessary for the cooling and collapse of gas into new stars. So what I do is I make maps of nearby galaxies, looking at the infrared light from dust. And I use that to infer how much dust there is and what it's made of and how it changes depending on where you're looking in a galaxy. There's an array of telescopes called the Atacama Large Millimeter Array in Chile that allows you to see extremely fine detail in the distribution of gas and dust in nearby galaxies. I've been using ALMA to try to understand how dust and gas interact in the Small Magellanic Cloud. This is a really cool galaxy. I also really like the Andromeda Galaxy, another neighbor of the Milky Ways. It's quite a bit further away and a bit older. I think what captures my imagination about studying the interstellar medium and dust is that it's a very complex system with a lot of different parts. It's a lot more like studying, I think, climate. It's trying to understand a complicated system, and that really appeals to me. I think it's also interesting because it's so fundamental to how galaxies work and how planets formed and how eventually we got to life on Earth.
Today on It's Okay to Be Smart, we're going to do a little bit of spring cleaning. Just clean that. It's all stardust anyway, right, Carl? Dust can be everything from invisible smoke to tiny sand. But to understand everything that it does, we have to go beyond this tiny speck. Space is mostly space, but it's not empty. A cube 100 meters on a side would still have maybe 20 specks of dust inside of it. That stripe of the Milky Way across the night sky, that's dust. And in that are the atoms, the elements, and the chemicals that made all of this. Our sun and planets and moons and asteroids and comets, everything in our solar system began as a cloud of dust. 5 billion years ago, gravity began to sweep that dust into a pile, and millions and billions and gazillions of particles condensed into the solar system that we have today. And some of that dust is still up there today, a thin cloud left over from the disk that formed our planets. And on spring nights, if it's dark enough, you can still see it glowing in the western sky after sunset. It's called the zodiacal light. Of course, not all of it stays up there. Odds are a piece of space dust falls on your head about once every day. And that means when you wash, say, your car, thousands of pieces of space dust are just running down the drain. And when we look inside that space dust, we find the same elements that make up the Earth itself and everything on it. When we look inside that space dust, we find the same elements that make up the Earth itself and everything on it. Dust can also kill. According to the WHO, not the band, 1 in 8 deaths worldwide can be traced to air pollutants, which is mostly our fault. Hannah Holmes says that air is the medium and dust is the message. With every breath we inhale a bit of the story of our universe, our planet's past and future, and the smells and stories of the world around us, even the seeds of life. In other words,
dust, wind, dude.
So next time you wash your car or sweep behind the couch, just remember, Earth is one big dust bunny.